Konnichiwa, my name is Adolfo Jara and I'm from Paraguay. I'm a PhD student on Kyushu Institute of Technology. In the Birds4 satellite project, I'm responsible for the onboard computer OBC, which in other words is the brain of the satellite. Some of the OBC main functions are the execution of commands sent by ground station through the contact system, collect, store and transmit housekeeping data and mission data, monitor the general status of the satellite, and execute commands automatically. To fulfill these functions, the OBC works in coordination with EPS subsystem and with COM subsystems. Thank you very much.
Hello everyone, I'm Aníbal Mendoza and I'm from Paraguay. I'm also a student of Master in Space Systems in Kyushu Institute of Technology, and I'm also a member of Birds4 project and mainly responsible for structure and thermal subsystems. The main functions of these subsystems are to provide support and arrangement for the payload and all other subsystems, protect them from external environment, make sure that satellite passes the qualification requirements for under vacuum conditions, extreme temperatures, to ensure its functionality in a space environment.
Hello, Namaste. My name is Hariram Shrestha. I am from Nepal. I am doing my master's degree in QTech at Space Engineering International course, as well as I am also Birds4 team member. My responsibility in the Birds4 project as electrical power subsystem. EPS subsystem is an important subsystem for CUBESAT. We can see here FAB, front access board, battery and OBC is the major role for EPS subsystem. The main function of the EPS subsystem has to generate power. So what we can do, so we use solar power cell, we can see here. So this is the generated power from solar cell, and this is the secondary rechargeable battery. So we are using nickel metal hydride battery for our energy storage time. So this battery are using in eclipse time. That time this battery will be like a power source. And the another important things of EPS subsystem is to management the power. So FAB and OBC is the management part to distribute and to control the current and voltage to the missions and another subsystem. So we are using here reset peak. So reset peak is controlling to energy to subsystems and missions. So battery is inside the between of the FAB and OBC. So FAB is collecting the data to give OBC when OBC send to command FAB. And finally we have there are three electrical and mechanical deployment switch here. So this is the we can see also push button switch. This one is related with JAXA requirement. So we are using one is here rail switch and another two is the push button switch here and this side. So we control the power before to deployment our satellite. After 30 minutes later it will be work or it should be work for the CUBESAT.
Konnichiwa. I'm Hiroki Sasugu from Japan. I'm responsible for the active determination and control system on Birds4 project. In this mission, we aim to demonstrate active active stabilization using 3-axis magnetic token. After that, we will do active determination using the triad algorithm. After the satellite active is determined, 3-axis nadir pointing is done using 1-axis reaction coil and 3-axis magnetic token. In this mission, we use a commercial brushless 3-phase motor as a reaction coil. To this mission, our objectives are to observe in space characteristics of each sensor and actuator, and to design an active control system for future Birds ADCs.
Hello, my name is Hudaami. I'm from Egypt. I joined Birds4 as part of the Japanese team after we proposed the secondary mission of image classification unit. Currently, I'm involved in another mission, which is Store and Forward, specifically in the development of the ground relay terminal, which will collect data from the sensors and then uplink it to the satellite, and it will be downlinked later to any of Bird's ground stations.
Good day, everyone. I'm Israel Zenar Bautista from the Philippines, and I'm the project manager for Birds4. As the project manager, my job is to keep the project timeline on track and make sure we complete our milestones on time. Aside from being the project manager of Birds4, I'm also doing the perovskite solar cell mission for our satellite. In this mission, we'll be flying a new type of solar cell called perovskite solar cell, which is manufactured by the MA Laboratory of Kyushu Institute of Technology, Wakamatsu Campus. We will measure its in-orbit performance using a solar cell measurement unit inside the satellite. This measurement unit is in the rear access board, and it characterizes the IV curve of the solar cell and saves it into flash memory for later download when the satellite passes over our ground station. Using the data we gather, we can gain more insight on the visibility of this low-cost solar cell for space applications.
Hello everyone, I'm Mark Angelo Puyo from the Philippines, and I'm part of the Birds4 satellite project. I'm responsible for the camera mission and the backplane board design. So the Birds4 satellite project is utilizing the backplane board. So the backplane board is responsible for connecting each of the boards together using a 50-pin connector. So when we use the backplane board, we avoid harnesses. At the same time, we'd be able to easily connect all the boards together within the satellite structure. For the camera mission is using a commercial off-the-shelf component camera, the OV5642. So the same as the other Birds project, we are in a heritage of using the same camera. So what it does normally is it takes photos from space, and we save it in a flash memory, and we downlink the data through our ground station. So what's different from the camera mission of Birds4 with the others is now we will be communicating with the image classification unit and the attitude determination and control system. So with the ADCS, we connect it to the camera so that we do the target mode. So if the satellite passes to a certain country, participating countries, then we'll be able to take the photo or image of the country itself.
Konnichiwa, I am Marlon Jara from the Philippines, and part of the Birds4 project working on the communication subsystem. My responsibility is to make sure that the satellite is constantly and reliably communicating with the ground station. So I will show you the components of the communication subsystem. First off, the antenna, which is placed in the negative Y panel of the satellite. So this is the UHF dipole antenna, which is used by communication subsystem, and it is perfectly tuned at 435 to 438 megahertz. The next important component is the UHF radio transceiver. Its transmission and reception is rated at 4,800 bps, and it is also capable of CW. So this radio transceiver is connected to the antenna and connected to the compig, wherein the compig is communicating with the main peak for housekeeping and mission data information. Welcome again. Aside from communication subsystem, I'm also responsible for the APRS Digibit mission. So the objective of that mission is to receive amateur signal from amateur radio community and digibit it back to the ground stations. So important components are, number one, again, the antenna. This time it's VHF, tuned at 146 megahertz. This antenna is also dipole, but the placement of which is far from each other. So we use what we call a strip line for it to have connected to the feed line. The next component is the radio. So we use COTS radio from Radiometrics at 146 megahertz of frequency. It is capable of transmitting 500 milliwatts of power. And finally, the APRS TNC, which is at the back of the board, Mission Board 2. So we use the circuit similar to the one used by Tiny Truck, as well as their main.
Hello, my name is Tomoaki Murate. I'm in Japan team. My part is TMCR mission and NT mission. TMCR mission is check the radiation effect for MOSFET. If I can check the degradation, so we can prove the disability of that component. Moreover, we can use it as a dot meter on orbit. And TMCR mission is checking new component. I cooperate with NTU from Singapore. We can check this also. We can check radiation effect for new components.
Hello everyone, I'm Daisuke Nakayama from Japan. I'm responsible for antenna mission. This mission demonstrates new antenna design. Dipole antenna are often used for CUBESAT, but dipole antenna requires deployable system, but it's risky for safety and reliability. Therefore, we designed antenna. The structure functions as an antenna. Basco satellites transmits to our ground station with antenna, and we can evaluate antenna performance to receive the signal. Thank you.
Hello, my name is Yuma. I'm from Japan. So my responsibility is the antenna deployment system. The purpose of this system is to deploy antennas successfully in orbit. So before the satellite, you can see the antennas are low. So the burner should deploy antennas in orbit after they are released. So if antennas do not deploy, so the satellite cannot communicate with ground station. So it means the satellite is dead. So it is so very small, but very the difference between the Basco and the previous satellite is that so we use 4 antennas, which are YouTube and YouTube dipole. So it is the first satellite that will use 4 antennas among QTech satellites. Thank you.
Hello, my name is Timothy. I am French. I am in charge of the image classification unit mission. Its objective is to classify photos taken by the camera mission using machine learning. Being able to classify images before downloading them to ground station will allow us to only download the most useful photos and avoid downloading the useless one.
Hello everybody, I'm Yasser Abbas. I'm from Sudan. In Birds4, I'm part of the Japanese team. I'm working in 2 missions. One is the store and forward mission, which is the mission that allows the satellite to collect data from distributed sensors all over the globe. The other one is ICU. ICU stands for Image Classification Unit, which is an experimental subsystem used to optimize the camera performance. To tell more about Store and Forward mission, as I mentioned earlier, it's a mission that collects data from distributed sensors from the ground. The sensors send the data via RF in APRS format. That's why I simulated the signals using a handheld radio. So the signal from the sensors goes to the satellite and is received by this transceiver here. Then the information goes through the TNC, the terminal node controller, to the MCU of the Store and Forward mission. The MCU then generated or extracted the data and save it in a local flash memory to be forwarded again to the ground stations.
Hello, my name is Yiğitçay and I'm from Turkey. In the Birds4 project, I'm the responsible for structure subsystem and I'm managing the subsystem subteam as well as taking care of the documentation and preparation for the safety reviews done by JAXA. My part can be described as ensuring the satellite is smoothly inserted to its orbit and it's getting prepared properly for the conditions regarding the launch vehicle and JAXA regulations.